chromatography to separate amino acids. We're going to look at 3 amino acids. These are lysine, leucine and glycine. The first thing we're going to do is set up our chromatography tank, and we're going to add a running solvent, which is a mixture of butanol in 6 parts, glacial ethanoic 1.5 parts, and water 2.5 parts. You see that? This is the running solvent. I'm just going to add that to our beaker. And then we're going to replace the lid, and we're going to leave that so that we create an atmosphere of solvents. Next, we're just going to take a piece of chromatography paper, and we're going to draw a line 2 centimetres from the top and 1 centimetre from the bottom, like so. So the top area is where we're going to handle the paper. We're going to get rid of that in a minute. And then next, on the bottom line, we're going to place dots, which is where we're going to place our amino acids to run them. So we've got 4 samples. Okay, my dots aren't very well spaced, but hopefully yours will be better. We're then going to place the amino acids. So I'm going to label them, the first one with a G for glycine, second one with an LY, third one with an LE, and then we have a mixture of 2 amino acids, and we should be able to work out which these are once we've run our chromatogram. Okay, so we just take the lid off the amino acid glycine and use a cocktail stick. So just put a very small dot on there. I'm going to do that several times just to make.
As you go.
Okay, so I'm going to cut the very sharp ends off these cocktail sticks just to help them pick up some of the amino acid. Just cut them out. So the next amino acid is lysine. You see that? I'm going to dot that. Then we'll use leucine. And finally, our mixture. you've dotted all the amino acids, we're going to roll the paper into a cylinder like so, and use a little paper clip just to clip the top. Like so. And we're then going to place that into our tank or beaker. Right, I've forgotten something, sorry. I'm going to cut this top part off first. Okay, I'm going to cut just the top bit off the paper, which is the handling area. And then carefully drop into a still handling it a bit unfortunately. I've done a very good job of this. It does take a bit of practice, but clip that on the top. And then that will go into the tank. That'll fit there. Yeah. You don't want it to touch the sides of the beaker. So I think the solvent in my tank is a little bit too deep as well. So when you do this, it needs to be a little bit shallow, or the line needs to be a bit higher. But we'll see how we go with that. Now. So actually, I've decided to change my chamber for a longer beaker with no lid, so we get a better seal with the lid, and we also don't have to chop the top of the paper off, so it just makes things a little bit easier. So I'm going to put this into my chamber. Not touching, is it? Put the lid on and then leave that to run probably for about 15 to 20 minutes, and then we'll have another look.
Oh, here we go.
Okay, so the solvent has now moved up the chromatography paper, so we're going to take this out now. Ideally this should all be done in a fume hood. This is quite volatile, nasty solvent, but I can't do that for the film, so, but normally it would be in a fume hood. So we'll take the clip off the top, and we need to mark the solvent front, which is just here. This is where the solvent has moved up to. And we're then going to use a hairdryer to dry this as quickly as we can, to stop any more movement. Okay, so my paper's dry now. I actually did take this over to the fume hood. To do that, I've brought it back. You can't see any of the amino acids at the moment. They're invisible. So what we're going to do is spray this chromatogram with ninhydrin spray. You've probably seen this on some of the crime scene programs. I'm going to spray the whole of the paper with ninhydrin, and this should develop the amino acid spots. I'm going to do this in the fume hood because, as you can see, the spray's also not very nice. So I've sprayed the chromatogram with ninhydrin spray, and then I have dried the paper under heat, and as you can see, the spots have developed. These are the amino acid spots: lysine, glycine and leucine, and this is our mixture. We've measured the solvent front here, and we need to measure the distance that each of these spots have moved, and then work out RF values for each amino acid. But you can see that in the mixture you have lysine and leucine.